Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Secure Model for IoT Healthcare System under Encrypted Blockchain Framework. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the research area which is specifically designed for the medical domain for the latest technology blockchain and encryption related data. So this is one of the advanced research which can be done for the industrial, for the doctorate and the other domains. So before starting this video, let's talk about that, what we will cover into this video. In this video, we will initially discuss that in which application areas this research can be implemented and what are the real-time scenarios where it is useful. Then we will talk about that what code we have implemented, how to execute that code, and what are the software requirements for it. Then what are the current systems and what are the problem identified in them, and finally what we have proposed in the system. The last is that what are the experimental outcomes after the simulations conducted and how our proposed system is superior to the existing system. So this will be discussed into this video. Let's talk about the application areas firstly. In the application areas, as the different technologies like blockchain, data encryption techniques are specifically designed. So this is related to the medical domain. So the application area is specifically designed for the biomedical applications, for the healthcare society, where the data can be easily secured and can be placed on the servers without getting access to the unauthorized person. In the foreign countries and even in the recent areas where nobody want to share their medical as well as their personal details with anyone, so it is a very crucial information related to any of the individual. So in order to handle that, we are proposing this application by using the recent technologies of blockchain, on which basically the other recent domains are working on. So because blockchain is one of the secure domain for the data handling, so it is also related to the cyber security and the data protection. So it is not restricted only to the healthcare. But why healthcare? Because we are developing this application for the healthcare data only. But it can be further proceeded to the cyber security, data security, and the protection areas. So now let's talk about the code that we have designed. So we will provide you a folder. So this is the folder under which the whole code is there. So this is designed in the MATLAB. So you need a MATLAB software along with you, in which you can run this code. In order to run this code, you must have the MATLAB 2019 version. Even 2018 can also work, but make sure it should be a full version of the code, full version of the MATLAB, because instead of getting the full version, the trial version will not have all the libraries with them to run it. So in order to run this code, you just need to go to the folder where the code is placed. Here it is the location where the code is placed. You just need to copy this path and then go to the MATLAB. Here in the upper window, you just need to paste it, press enter. When you press enter, the whole code, whatever is available in this particular folder, will be shown here in the current folder. So in order to run this code, we have different scenarios. One of that, firstly, we have done the analytical part. So for the analytical part, we have individually implemented two of the algorithm, then our proposed algorithm, and finally did the comparison for it. In the second scenario, we have developed one of the application, which is a real world hospital based application under which the things can be done. So for that, you just need to go and run the front.m, in which graphical user interface has been designed. So to run any particular file, you just need to select that file, open that file, and you just need to click on this run button. Once you will click on the run button, it will show you the outcomes. So let's talk about that, what exactly is currently happening and what we have done into the proposed system. In the base paper, we have chosen this base paper, which is recently IEEE access and specifically for the healthcare IoT systems, in which the data is handled by the blockchain one. So what they have implemented one of the scenario in which the user's data is initially encrypted by the ECC, and then in the block based scenario it is transferred from one position to another, and the transactions has been done in the blockchain. But we have arised the problem that ECC is one of the algorithm which is very basic in the scenario of the encryption for the data, as well as the blockchain can be extended further, where the user level encryption of the data is also mandatory. So along with the blockchain itself is very much good, but if any of the block in the chain will be extracted by any unauthorized person, so it will be easy for them to extract the whole chain and can get the information. So in order to avoid the mining of the blocks from the blockchain, we are proposing this scenario. So the scenario that we are designing is basically for the initial one of the scenario is like we are proposing one of the encryption algorithm for the blocks, and then the encrypted data is divided into blocks, and by using the blockchain scenario we are transferring that data. So what we have done initially, we have implemented DES and RSA algorithm. So one of our algorithm is RSA. RSA is one of the encryption algorithm similar as of the ECC, but is better than of ECC, proven by number of the researchers. In this, we are using the actual patient data which is got from the Kaggle website. So you can see at the Kaggle you can get the data like Kaggle heart disease data set. So we are using this data set with us. You can get it from the Kaggle or you can get it from the UCI machine learning. So this is the actual patient's data set having the number of attributes related to their health in the heart disease. So this is the crucial data considered for the patients. So it is considered in our scenario. So in this, what we have done, we have used the data, and then on that data individual columns has been used for encoding. Initially one of the scenario RSA, we are dividing the whole data in the small blocks and then applied the RSA on it. So in this we have applied RSA with the blockchain. So this is RSA encryption, and then applying the encryption with the RSA encoding, and then the decryption has been made, in which the decryption results has been also extracted. So this is encryption and decryption at the same time for the RSA, where the data is divided into small sections, and on that we have the encryption and decryption is done. We are calculating the encryption and decryption time, as well as MAE, MSC and RMSC factors for evaluating the system. Similarly, the same scenario has been done for DES algorithm, which is also an encryption algorithm. So similar scenario for the RSA is considered in the DES in order to see that how much time and other related factors have been extracted out by using the existing DES algorithm. But these algorithms are already implemented and having few challenges while working with them. In order to avoid that and to provide more security, we have proposed one of the algorithm in which we are using AES and SHA encryption algorithm. So this is the proposed scenario in which initially we are generating the key from the AES method and then applying the SHA encryption method. In order to SHA 256 hasher has been used in our proposed method to encrypt the data, and then we are calculating the same parameters in order to show the effectiveness of our system. So the proposed scenario is having the similar scenario for RS, which was used for RSA and DES, but is the proposed one is the AES plus SHA 256 hasher, which is the advanced encryption methodology used in the current scenarios for data communication. So when we are running this code, as you can see, I'm going to run the RSA. So when we are running it, it is taking the data, processing it, encrypting it, decrypting, and showing you the outcomes in terms of the factors that we have analyzed. So you can see this is the time for the encryption. The decryption, it is in the seconds. This time depends upon your system configuration, so this only cannot be the evaluation factor. So other than that, RMSC, MSC, MA, all these factors have been evaluated. Same has been done for DES and proposed one, and we have saved the result by using the command name save. So by saving, you can save the results whatever we have achieved, and then in the final comparison file we are loading those files whatever are executed during the simulation of these different factors, and the results has been shown. As I am going to run it, you can see the results where the different analysis sectors, as you can see, these factors has been there. For the MA, the variation is more. For RMSC, variation is more. MSC, variation is more. So it is considered that as much variation among the data will be higher, that efficient the system will be. Let's see an example. For example, if do we have 1 2 3 4, and the encrypted outcome is equal to 1 2 4 4. So obviously it is having only 2 bytes variation, 3 4 2 3. So only the one variation, right? So obviously if I'm gonna see the MSC, it will be 1. But what if we do have the input, like for example, instead of being this, it is 5 5 5. So you can see there are 3 bytes variation in this, 3 numbers are varied. So obviously the error will be more. So as much error will be more will be the variation, and our system will be more efficient. So you can see in the proposed scenario our system is efficient enough. So this defends that our given system is more providing variability to the data, so that it cannot be easily decrypted by the unauthorized person. So holding this, we have implemented it in the real-time scenario where the blockchain is also clubbed with the proposed hybrid method of AES and SHA-256 hasher. This is the application that we have designed. It is a graphical user interface application under which you just need to run the front.m file. In this application, what we have done, it is basically a hospital related application under which you can register, you can log in and exit the system. During the registration purpose, you have the authority under which you can give your username, your contact name, user ID, password, and type of the user. User can be patient and the doctor. Let's see if I'm taking any of the example. For example, username AST, contact number, it can be 46464645, sorry, 45. User ID can be 12345, password can be 456789, and user type is patient. Click here to upload the picture. Any of the picture you can take. It can also be further extended. This is the prototype that we have designed. Let's say we have the picture with us like this. This is a picture with me. So when I click on the submit register, do take care of 1 2 3 4 5 4 5 7 6 8, submit register. When I click on the submit register, the registration completed as a patient. Go back, then you click on the login. So login is basically 1 2 3 4 5, password is 456789, and the login type is patient. When I click on the login, we have randomly assigned the data from the heart disease data set to that particular patient, where all the factors like patient, this, all these factors will be given, and whatever the doctor will be given, as I have already registered as a Deepak here. You can see the assigned doctor is Deepak. So all the information will be shown to the patient only. Now what about the doctor which is in the hospital? So if any of the doctor is there, he has to log in. For example, I am registering, I am just going to log in as a register. So here I'm going to see the patient registration and the information, because for that I just need to go to the doctor data. So I am just clicking it here, but it will be obviously on the server, so cannot be accessed. So but because we need to show it as a prototype, I'm going to see the doctor details here. So doctor data is basically having the different doctor names. As I can see, for the doctor name that I have taken was Deepak, and the user ID was Deepak, and the password was Deep123. So I'm gonna log in again. So I'm running the whatever the code is already running. So I'm logging here. So as a doctor, I just need to log in here, Deep123, and the password is DEEPAK. So as a doctor, I am logging here, login. So you can see this will be the interface that I will get, under which we have a list of patients, those who are allotted to that user, that doctor. So I'm selecting one of the patient. This is the recent one with that is registered with this doctor. So I'm selecting this Vivek. When I click on the Vivek and clicking on the submit selected patient, so this is the information that related to their age, sex, whatever the blood pressure and cholesterol values, all the credentials, but in the encrypted form. So here you can see if any of the block can be extracted from the chain by the unauthorized user, they will get the data in the encrypted form, not the exact form. So it is the dual kind of the security provided to the user, right? So now in order to get the authorized information, we have selected that they have to submit their credentials. So the credential submission is being done on the basis of like fingerprint. So we have kept the images of the fingerprint here. The sensors or hardware can be embedded to it in the future work. So when I click on the submit credential to decode, we do have, this is the credential for Deepak Doctor. So I'm just selecting it, click on the open. So when I click over it, you can see the information for the data as well as the patient's information is being done. Here you can see the contact, user ID, age, sex, chest pain, and all the information is get decrypted. So this is the real-time prototype that is driven out from the design system from our proposed work, and can be implemented in the real world scenarios, inspired from the latest technology of the blockchain, the encryption SHA-256 and AES based proposed methodology, which is proven to be the best in terms of the different factors. So further modifications are still possible because it is a very vast area of working with the blockchain and other technologies, and can be implemented in many of the domains. For any of the research related to the industrial, for the medical research, or for the doctorate level, you can contact us directly and can get the information. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.